Here is example 2 of using the alternate definition of the derivative. So we want to use the alternate definition of the derivative to find g primed of negative 2, where g of s is the square root of s squared plus 1. So in general, the derivative of a function g of s at s equals c, if we use the alternate definition, is the limit as t goes to c of g of t minus g of c, all divided by t minus c. So we want to find the derivative of g at s equals negative 2. So we're going to plug negative 2 in for c, and we have g primed of negative 2 is the limit as t approaches negative 2 of g of t minus g of negative 2 all over t minus negative 2. So g of negative 2, well, that's just going to be the square root of negative 2 quantity squared plus 1. Negative 2 quantity squared is 4. 4 plus 1 is 5. Well, we'll get there soon. G of t is the square root of t squared plus 1, and on the bottom, t minus negative 2 simplifies to t plus 2. So here, in the numerator, we have square root of t squared plus 1 minus square root of 5, as we mentioned earlier. And now what we want to do is get rid of these square roots here. So we could try direct evaluation now, but that's going to give us 0 over 0, and that's bad. Mostly bad because it tells us that there's something else that we can do. And in this case, what we want to do is rationalize the numerator. So we're going to take the entire numerator here and the denominator and multiply both by basically the conjugate of the numerator, the square root of t squared plus 1 plus root 5. So in the top, we're going to FOIL. And in the bottom, we want to leave the bottom factored. So in the numerator, what happens is we have first, outer, inner, last. Outer and inner cancel because we have plus root 5 times this minus root 5 times that same thing. So those cancel. But for the first, we have square root of t squared plus 1 times square root of t squared plus 1. So we end up with the square root of t squared plus 1 squared, which just gives us t squared plus 1. And then minus root 5 times positive root 5 is minus root 5 squared. But if we square root 5, we just get 5, and we still have a minus sign here because the minus was outside. So we have negative root 5 times positive root 5, so we just end up with minus 5. Now, again, leave the denominator factored and bring that expression to the next page. So then when we simplify on the top, we just get t squared minus 4 on top. And on the bottom, we still have the same stuff, and we're still taking the limit as t goes to negative 2. So now what we want to do is factor the numerator. So we end up with the limit as t approaches negative 2 of t minus 2 times t plus 2, all divided by t plus 2 times this expression over here. Well, this is great now because our t plus 2 factors can cancel. So when we cancel those, we just end up with the limit as t approaches negative 2 of t minus 2 on the top, and on the bottom we have square root of t squared plus 1 plus root 5. And these parentheses here in this step right here, they're actually not necessary at all. It's not really wrong to have them, we just don't really need them. But anyway, now we can do a direct evaluation. So when we do that, we get, because we're taking the limit as t goes to negative 2, what we want to do is directly substitute negative 2 in for t. So we get negative 2 minus 2, all divided by the square roots of negative 2 squared plus 1 plus root 5. Well, on the top, we just get negative 4. Negative 2 squared is 4, plus 1 is 5, so root 5 plus root 5 on the bottom, which is really negative 4 divided by 2 root 5. And we can simplify that a little bit and say that's negative 2 over root 5. So that's our final answer. G primed of negative 2 is negative 2 divided by the square root of 5. And there's really no point in rationalizing the denominator here, so we'll just leave that as this. And that's our final answer for example 2.